Today I'd like to expand the concept of modular systems and congruence to a multi-dimensional aspect, either using, instead of simply real integers, complex or hypercomplex integers. In the case of this example, a complex example, 25 plus 3i is congruent to 1 plus i with a modulus of 3 plus 2i. Now, in cases like this, in the complex or hypercomplex cases, we take each corresponding part to the corresponding part in the modulus. So in other words, this 25 is real, so we find the remainder when divided by 3, that gives us 1. Then we go to the imaginary part. The 3 over the 2 gives us, once again, 1, but this time 1i. And if we have hypercomplex cases, again, each corresponding term, we apply the rules of remainder theory in each case. And for any missing terms, we put a 0, right? So if we have a hypercomplex case of, say, something plus something, I plus something, j, and we have an I missing, and in the applied number, we put a 0 there. Okay, well, how about taking a case of a matrix, and we make a matrix as a modulus. Okay, in this case, right, we have a 3 by 3 matrix as a modulus, so we like to apply 3 by 3 matrices. And again, in each case, we look at the corresponding elements in each matrix, and applying the rules of remainder theory, we get our congruences. So even though we would like to have matrices that match in their size, precise size and dimension, could we have matrices that are larger or than the modulus? Yes, we can. And say, for example, we had a 4 by 5 matrix applied with a modulus of 3 by 3, then what we would do is we would submit the 3 by 3, the square modulus, in each square segment of the 4 by 4 matrix. Get the results. We'd have a series of results which would be separated by delimiters. Now, conversely, if we had, say, for example, a 2 by 2 matrix applied to this 3 by 3 modulus matrix, then we would overlay the 2 by 2 matrix in every 2 by 2 section of the modular matrix, everywhere we find 2 by 2 section, and get a series of results there, and those would be also separated by delimiter. But note, we don't have to do any of this. It's just a shorthand for what would be a series of distinct but related modular equations.